Okay, hello everyone. Good morning, good afternoon. Thank you for joining us. My name is Carole Graas. I am the Program Director for the IEEE SUSTEC Initiative, and I would like to welcome you to attend here this new webinar series that we are kicking off today on the topic of technologies for a circular economy. I will spend about a couple of minutes introducing the series, and then I will turn it over to our presenter for today. So the United Nations tells us that in a world of finite resources and mounting environmental challenges, the traditional linear model of take, make, dispose is no longer viable. The circular economy offers a transformative approach that prioritizes the continual reduction, reuse, refurbishment, and recycling of products and materials. The shift to a circular economy also reduces the generation of waste and greenhouse gas emissions, making it an essential strategy in the fight against climate change, pollution, and biodiversity loss. In IEEE, we have a mission, as stated by our past president, Dr. Saifer Rahman, that we want to ensure that our response to climate change is substantial, appropriate, and properly engages IEEE, its members, and the larger technical professions. In order to meet this goal, we want to provide a neutral platform, and we want to function as a technology provider. So this new webinar series on technologies for circular economy is intended for a broad audience, not only the engineering and technical community, the industry, regulators, policymakers, community stakeholders, etc. It is intended for the general community with an interest in climate change, sustainability, clean energy and industry, the health of our planet, its resources, its ecosystems, and its inhabitants and related topics. We want to serve the needs of the profession and the public by increasing awareness and understanding of technologies. So this series is brought to you by the IEEE Future Directions Committee, and in particular by its SUSTEC initiative. It is also held in collaboration with the IEEE SUSTEC 2025 conference, which was recently held in Santa Ana, California, where the SUSTEC initiative kicked off the topic by offering a workshop, which included many of the speakers that we will be able to hear in this seminar series. Because of its success, we have decided to offer these talks in a webinar series, as well as we did in the workshop. So we have a preliminary program which starts today with our speaker, Dr. Maike Luiken, on the topic of why circular economies are needed. And if you look on our webpage, you will be able to see updates on our program, which as of today is offering the talks shown on this slide. Our next speaker will be Alan Booker, who will present 2 sessions on regenerative design. So speaking of our next presentations, it will be on July 17. Alan Booker is a founder and executive director of the Institute of Integrated Regenerative Design. His presentations are always eye-opening and fascinating, and we invite you to continue to attend our series and listen to Alan Booker in the next 2 presentations. If you do register, you have access to the entire series, so there is no need to register for each presentation separately. So today's talk, Why Circular Economies Are Needed, will be presented by Dr. Maike Luiken. She's the Managing Director of R&D at Carbovate Development, and she is an Adjunct Research Professor at Western University in Canada. Maike is a very well-known volunteer at IEEE. She has presented in many forums on topics of sustainability, and she will show you in her talk a little bit more about her expertise and will take us through this very important topic as an introduction to our series. So Maike, I turn it over to you.
Thank you very much. And you have unshared. So if you give me a minute. Somehow I seem to be getting a whiteboard here suddenly. Well,
would you like me to share your
it's
charts?
faster if I do it, but where did it go? I have it. Okay. It just went hiding. My apologies. So thank you very much for the lovely introduction, Carole. And it's my great pleasure today to talk a little bit about why a circular economy or circular economies are needed. A couple of words about myself. I've been working around and with sustainability-related topics for many years. Most, I think, since about 2005. And in that vein came up with a couple of bylines. One, that we do need to innovate, and if we interact, and IEEE is a formidable platform for interaction, we have a really good catalyst for innovation. Thinking about sustainability and sustainable development, people need to make decisions to people, corporations, organizations need to make decisions to act more sustainably. And for that, we truly need education. So between interaction and education, I think we can build a better world for all. Couple more words to show you a little bit about my background. I live and work since 2005 in Sarnia, Ontario. It was the birthplace of the North American oil industry, but also had about 10 years ago the largest solar farm globally with 80 megawatts. So it's a relatively small community, but very heavily into innovation. So this is our agenda. A couple of words about IEEE, then I'll go around our context, our global challenges, then describe circular economy, and have a few words about how we may get there. So about IEEE, as of the end of last year, we had over 486,000 members globally in 190 plus countries. We pride ourselves in being a source of trusted knowledge, a convener. We are involved with about 2,000 annual conferences. We have a publishing house essentially with 200 plus periodicals, and we are a standards developer. So we have about 2,000, close to 2,400 standards and standards projects going on. We are involved in global public policy, humanitarian efforts, continuing education, and are very much concerned about the ethical implications of technology on humanity, implications of technology on the environment, and so on. So let's go to our global challenges, and I'd like to start with the meadows, the limits to growth, which was very much publicized through the Club of Rome in the early 70s. So this is from 1972, and very clearly stated that non-renewable resources are finite. We have known this for quite some time, and many people have been worried about it for quite some time. let's jump forward to earlier this year. The World Economic Forum put out its annual global risk report, and the 10 most identified risks are identified for on the short term for 2 years and for the long term with a 10-year horizon. And you see the items in green are environment related. And so there's 2 on the short-term horizon with extreme weather events and pollution. But on the 10-year horizon, we have half the most important risks identified as related to the environment, from weather to biodiversity loss, critical changes to Earth systems, natural resource shortages, and of course, pollution. So environmental impact of our actions is becoming more and more important in assessing risks, risk to operation, and so on. Here's another way of looking at the current situation. This is from the Stockholm Resilience Center, and this group has identified planetary boundaries from climate change, biosphere integrity, land system change, and so on. And out of 9 boundaries identified, 6 have been crossed. In other words, we are using more resources, impacting the Earth, the planet, more than the planet can regenerate or heal itself from the impact on an annual basis. There's only 3 areas where we have not extended the boundary, and that is in the stratospheric ozone depletion, atmospheric aerosol loading, and in ocean acidification. And the reason we are okay on the ozone depletion and aerosol loading item is because we have taken action in that area before and still are. You may remember the very strong activities around the quote-unquote ozone hole. Going on, and let's talk about resource extraction. On the left hand of this diagram, you see the growth of resource extraction from 1970 to 24. And so the green is biomass, the purple is fossil fuels, the black is metals, and the blue are non-metallic minerals. And so you see that we have an ongoing rise of global resource extraction. And there's only just a small dip in at 2020, and that was during the COVID pandemic. So we are continuously extracting more and more resources. And we are also continuously emitting more and more carbon dioxide. So this is a diagram that is showing the CO2 emissions from 800,000 years ago to today, actually 2022, 23, I think. And you see that, generally speaking, the carbon dioxide level never went above the dotted line until essentially a few years ago in 1911. So what you see is, in terms of the sources, is ice core data, except for the red, which is measurements that are taken on Mauna Loa in Hawaii. So we started taking CO2 measurements in 1958. And so those are considered as modern data. The other one, of course, are ice core data. I've blown this up a little bit. So these are the emissions, but it's now all greenhouse gases, not just CO2. From 1850 to 2023. And again, we'll see a little dip for the pandemic, but otherwise, in general, this has been rising. There are a couple other dips. I'm not sure what the reason was, but we may want to look into that at some point. That could have been associated with volcanoes. Okay. Next, let's look at greenhouse gas emissions and warming scenarios. So we're translating now the trend of emissions and the correlation with warming temperatures and forecasting all the way to 2100. And you see that, and I'm not sure whether you can see my mouse, but hopefully you do. It's a little arrow. The black line is essentially what we are measuring today, where we are at. And so we have had a bit of influence with making changes. We are not on the top level of the purple, which is the the forecast for not taking any action on climate. When we go to the orange, those are the current policies, current as of 2021. Then we have the blue line, which is pledges and targets, and they are expected to get us to a rise of 2.1 degrees C. And then we have two pathways that are calculated, predicted 2.2 degrees Celsius pathway and a 1.5 degrees Celsius pathway. And you see that it's going to be difficult to achieve the 1.5 degrees Celsius pathway. It will take a lot of action to get there. And this was updated last in 2022. I've got one more diagram here that was updated in 2024. And you see here in the middle, it's essentially the same data, just looking different because it's from a different source, somewhat differently plotted. But you see that the orange arrow shows the gap between today and the target for 2030, if we wanted to get to stay on the 1.5 degrees C line, and also the gap in terms of implementation. So we do have pledges. That is the difference between the target and so we don't even have pledges that would get us to the 1.5 degrees C pathway. So the gap is significant between where we are today and in terms of implementation, and as well on the target side. So it's a lot of work to be done. Let's look at where those emissions come from by sector for a moment. And so the energy sector is the largest sector in terms of causing the emissions, almost like just over 73%. The second largest sector is agriculture, forestry, and land use at 18.4%. So third one, like then there's industry, and then there's waste, and that is the direct emissions from the waste from landfills and from wastewater. So that gives us essentially a goal in terms of where we want to make changes very fast and very effectively. So energy efficiency is the lowest hanging fruit, and going on from there. So we have looked at resource use, we have looked at planetary boundaries, we have looked at greenhouse gas emissions, and now where do we want to go? Where we actually want to go is have a long-term sustainability of the, or for the planetary biosphere. And biosphere is essentially the entire area of the planet where there are life forms. In order to get there, we can look at the challenges. They're achieving the UN Sustainable Development Goals. That includes SDG 13, which is climate change. So that's one big package of goals that are really well defined. We need to regenerate the Earth's ecosystems for the long term, those that we have destroyed. And we need to get to a circular economy that has at least nearly no waste and will then maintain long-term resources availability. And I've highlighted the circular economy piece here because that is where we are going for the rest of this presentation. So let's focus on the concept of a circular economy. There's a really well-written definition on the Ellen MacArthur Foundation's website. What is a circular economy? And essentially, it's a system where materials never become waste and nature is regenerated. So it mimics nature. In a circular economy, we keep products and materials in circulation through processes like maintenance, reuse, refurbishment, remanufacture, recycling, and compost. The circular economy tackles climate change and other global challenges like biodiversity loss, waste, and pollution by decoupling the economic activity from the consumption of finite resources. Okay, so key here is that there are three principles: eliminate waste and pollution, circulate the products and materials at the highest value, and regenerate nature, and drive this by design. So, for example, waste reduction or elimination of waste is not an afterthought. It is designed into processes. It's designed into products. And what happens is, with this transition to renewable energy and materials, the circular economy becomes a resilient system that is good for business people and the environment. Okay, so this is a definition from the Ellen MacArthur Foundation. Let's look at it in a couple of images where we contrast the linear economy with the circular economy. So the linear economy, as Carole was already introducing in her introduction, is essentially based on take, make, dispose. And essentially resources today are extracted faster than they can replenish. And the other consequence is that waste is piling up more and more. We also need to look at this a little bit in conjunction with population growth. I've mentioned a few times in previous talks that at my second last birthday, I had this little check on world populations, and I discovered that at that time, the world population had tripled since the day I was born. So as population is growing, we are using more and more resources. And we are emitting more and more greenhouse gases. So all these statistics that I was looking at before with you, of course, have also been impacted by there being more people on the planet, and more people are like to live with more consumer goods. Okay, so let's now contrast this linear economy with the circular economy. And you see here there's this design light bulb. So ultimately we start from design, produce, distribute, consume, repair, collect whatever cannot be repaired and continued using, and recycle materials and use these materials to start over again with design. The recycling of materials may not be very simple, of course, but we can even recycle garbage plastic by using advanced recycling or waste treatment processes, such that the residue, the material, the resulting material, can be used as feedstock to make medical grade plastics again. So it is possible, but it's in many cases expensive, but it's definitely technologically possible. Here's another diagram of a circular economy. And you see on the left the steps for the bio materials, essentially, renewables, and on the right, the different steps for the finite materials, which is essentially a stock management piece. So you see share, maintain and prolong, all the way to recycle and come back. On the bio side, we'll have cascades, and we may end up with some biogas. We regenerate the biosphere. We come back with materials and can have parts manufacturing, products, service, and so on. Okay, here's another take at, in this particular case, carbon, the circular carbon economy. So we do have the living carbon, which is the regenerative biosphere. This is our example of a functioning balanced system. Now, we have been taking carbon out of the ground with fossil fuels and coal, and we will presumably continue doing so. But what we need to do is we need to use those resources only to manufacture durable goods. So it's a durable carbon, and we call it a circular technosphere. And we need to do this for other materials as well, not just carbon. But we cannot burn it for energy. We will still have emissions. I don't think we can, like, nobody is saying that we can totally avoid greenhouse gas emissions. So we do have to also come up with a way of capturing CO2 and methane, etc., to avoid further imbalancing the atmosphere with greenhouse gases. So let's talk more about what happens in a circular economy. It tackles resource limits by reducing demand for virgin materials, extending product lifespan, promotes regenerative inputs, minimizes waste, enhances resource security, and it is driving innovation and new business models. Another way to look at it is by an organization called the Zero Waste International Alliance, starting on the top with rethinking design, reduce, reuse, recycle, looking at material recovery, residues management, and the unacceptable but sometimes necessary for, say, hazardous material is the incineration of waste to energy. For example, if material has pathogens that need to be incinerated. Okay, so let's look a little bit at the how. I've repeated again the circular economy: eliminate waste and pollution, circulate products and materials, and regenerate nature. So Baumgart and McDonough, in their book Cradle to Cradle, essentially specified 12 principles of green engineering. The outputs would have to be non-hazardous, prevent waste, minimize energy consumption and material use, maximize mass, energy, space, and time efficiency, target durability, if you design for an unnecessary capacity or capability, that would be considered a design flow. Promote disassembly and value retention. Other performance and a commercial afterlife. So systems should be designed in such a way. And also materials and energy inputs should be renewable rather than depleting. Another approach is from Morcelletto. This is from 2020 from a publication to look at the way we handle resources, conservation and recycling. And so that essentially focuses on 10 R's from refuse, rethink, reduce, reuse, and so on, all the way to recycle and recovery. So smarter product use and manufacture, extend the lifespan of products and its parts, and look at useful application of the materials. In order to do that, we need tools. And I just put a very few here, like project planning tools, for example. Canada Natural Resources Department put out a tool called Red Screen for planning of infrastructure, for energy management and so on, low carbon planning. Then we need life cycle assessment tools for different products. Early on, there was a lot of work done on life cycle assessment for ICT devices. We need to measure the emissions, so we have the greenhouse gas protocol that specifies the scope 1, 2, and 3 emissions, and I realized I've got 3 and 3, but should be 1, 2, 3. We need reporting tools for ESG, environmental liability. We have one called Basic Sustainability Assessment Tool, BSAT, and we have the incoming Digital Product Passport by the European Union. So we are actually looking at a little bit at an evolution here from with respect to innovation and standards. So we manufacture to standards to start to make it work. We produce widgets that fit together, so it's interoperability. It's enabled by standards. We have safety standards, so the widgets are safe to use, safe production processes. And today we add to the above that we include ethical principles and strong sustainability by design. So if you're looking at it in terms of evolving from the then to the now, when we first started building quote unquote widgets, things, we were focused on making it work, then to make it work safely. And today we are looking at building items, infrastructure, widgets such that they are sustainable and follow a circular economy design. So I like to call that a sustainability culture. So what are the drivers of change then? If we want to make all these changes, we need the drivers. So one is information, data, knowledge. Ultimately, that will enable sustainable procurement. We need technology, presumably, some new technology, innovation, need standards. Other drivers are consumer behavior, corporate behavior, government policy and regulation, economic opportunities, and of course, societal values and goals. And I will talk quite a bit about regulation. So regulations coming in now at this point from the European Union, for example, is the Eco-Design for Sustainable Products Regulation from 2024. And you see here the core requirements. Those are the requirements that we talked about with respect to circularity. And there's another requirement on the bottom, and that's the information requirement, and that's the specification of the digital product passport. A few more words about this eco-design legislation or regulation. So it's a framework for setting the eco-design requirements and essentially applies to any physical goods that are placed on the market or placed into service, including components and intermediate products, except food, feed, medical products, veterinary medicinal products, living plants, products of human origin, and products of plants and animals relating directly to their future reproduction. So this is a very game-changing requirement, and I'll go into a few more aspects. So, for example, for mobile phones and tablets, the eco-design requirements talk about extending the lifetime. And there's a little statement here that if the lifetime of smartphones in the EU, of all of them that are currently in use, by 1 year, would save 2.1 million tons of CO2 per year by 2030. So it's the equivalent of taking 1 million cars off the roads. So the requirement then is to improve circularity. Battery life has to be at least 80% after 800 cycles. Spare parts have to be available within 5 to 10 working days and for 7 years. The operating system upgrades have to be available for at least 5 years. And I think I have an example here. Yeah, so this is what this is going to look like. So this is the label. And we essentially talked about all of this. So there's the repairability class, repeated free-fall reliability class, and added to it as well. And this comes into effect tomorrow, by the way. So it's effective June 20th, 2025. And it's for tablets and mobile phones, except it doesn't apply to flip phones. So be interesting to see what this looks like. Okay, so I mentioned the digital product passport in terms of in terms of the information requirement coming forward in this eco-design regulation. And so the benefits are expected to should be the tracking of raw materials and extraction and production, benefit market surveillance authorities and custom authorities. Manufacturers will have quite a bit of information about the product use. The repairability, second life, and so on can be tracked. And citizens will have access to verified information. So what this is going to look like is there is essentially a QR code on the device that will carry information or link to information that relates to the manufacturer, the greenhouse gas emissions, the materials used. It will, like, essentially everything that comes with a product to start with. And then it will add to it during its lifetime a repair record, and it should have information as well on the handling at end of use or end of current use. So these are the benefits that are expected by having a digital product passport associated with those goods in the EU. And these are the value chains that are under consideration. And so that's electronics and ICT, plastics, packaging, textiles, construction materials and buildings, food, water, and nutrients, and like vehicles and batteries. And the first one that is going to be mandatory is the digital product passport for e-vehicle batteries and industrial batteries. It comes into effect a little bit under 2 years from now, February 18, 2027. So this is happening. And it is called the Circular Economy Action Plan for a cleaner and more Competitive Europe. It's a very interesting document. If you have a chance to Google it, to find it, have a look. It's very well written. Okay, then. So I talked about general drivers for change. So let's talk about private corporations in terms of drivers. And so the top drivers are mandatory regulations. And here is the Digital Product Passport. Leadership, alignment with an organization's purpose, peer pressure, stakeholder pressure, risk management, and of course, a convincing business case. So those are the top drivers that were identified in a Sustainable Public Procurement 2022 Global Review. Okay. So a bit more on IEEE. Here are the related IEEE activities. So Carole introduced IEEE Future Directions, and within it we have the IEEE SUSTEC initiative, and we have globally IEEE-wide, we have a site called Climate Change. You may want to refer to that. And on the IEEE Standards Association site, we have the IEEE Planet Positive 2030 initiative. And you're invited to have a look at all of this and join various activities under these programs. And here are a few listed. So I invite you to engage, participate, and contribute to these various groups. The SUSTEC initiative, Planet Positive 2030, standards activities. There's a Young Professionals Climate and Sustainability Task Force. You can form within IEEE a local group, focus on any of these topics at your location. Join other initiatives in IEEE, propose a new initiative. If interested, get in touch with me, get in touch with Carole. As I said, engage, participate, and contribute. In summary, then, let's go back here. The key principles of the circular economy. Why are circular economies needed? They are needed because we do need to eliminate waste and pollution. We do need to circulate products and materials, and we do need to regenerate our natural systems. And the benefits are global. They are environmental by reducing waste, pollution, biodiversity loss. They are economic because they lower costs, create jobs, generate new markets, reduce material dependency, raw material dependency, and fosters resource security. And of course, social, because a circular economy will increase resilience, equity, and well-being by ensuring that those resources are available for future generations and communities. And ultimately, we do want to build this long-term, healthy planetary biosphere so that people and all living beings can enjoy this planet and for a long time to come, not just 50 years or 500 years, but 5,000 and more. And with that, I thank you very much.
Thank you so much, Maike, for this very comprehensive presentation. We now have a few minutes for questions and answers. If you would like to ask a question, please type it in the Q&A area at the bottom of your screen. I didn't mention, but Maike is also our co-chair of the SUSTEC initiative. And we have our other co-chair here online as well, Dr. Wei-Jen Lee. Dr. Lee will now moderate the Q&A time. So Wei-Jen, are you ready to start our Q&A? And can you see the questions that have been asked? Wei-Jen, you're on mute. Hello, Wei-Jen, can you hear us? Okay, so I'm sorry, Wei-Jen has some connections issues, so I will go ahead and ask you, Maike, the first question that we see in our Q&A. The question is, whenever we can find guidelines that will apply to improving waste and energy consumption by technology groups, so where would those guidelines be found?
Good question. I think, thank you for the question, Babita. I think it was yours. There are many different guidelines. I would actually go on the web and look for Google, ask the question and look for the guideline, because it's different groups have different guidelines. So if you want to talk about improving energy performance for driving, for example, you'd have to look for vehicles, and they will tell you that if you don't drive faster than 100 or 80 kilometers per hour, you will actually save quite a bit of fuel or electricity, depending on what type of vehicle you're driving. So it really depends on what technology you're looking at. I think that's the approach I would take. There's other guidelines on consumer products like laptops, other equipment that you have in your house, in your office, in terms of, for example, turning equipment off when it's not in use, because you have essentially all this equipment that is on standby using power while it is on standby and not fully turned off. So there's another guideline that you may want to look for.
Thank you, Maike. Our next question is concerning us as individuals. How can we approach this concept of circular economy locally by ourselves, with our friends?
Well, I read of a few groups that started really focusing on not necessarily secondhand shops, but actually having local share economies. So I see it a lot around young families with children that have a local share economy, where if like a stroller is no longer needed by one family, that it is passed on to the next, and people essentially post what they have available free of charge and make it available to others. I think that's a very simple place to start. But I think the other piece, of course, is we need to talk about it. We need to talk about not wasting. One other thing you can do is you can compost your food waste, which is also a big part, and actually reduce your food waste is a more important part to start with, because that's another part of waste.
Yes. Now switching back to designers, product designers. The next question is, what should a product or protocol designer should do to support a circular economy?
Well, I think in my presentation there were quite a few hints actually in that direction. So we need to think about what material are we going to use for a product, and how can the product be taken apart at the end of use, so that either parts can be reused or at least the material can be separated properly, so that the material can become feedstock, or the different materials feedstock for new devices. So for example, we often have plastic glued onto cardboard for packaging. I've seen new packaging coming out of Germany where they use a little bit harder plastic, recycled, classified, and it's sort of slit into a cardboard, but it separates. It's not glued together. It separates apart without, like, you don't have a composite, so to speak, material between plastic and cardboard that cannot be separated. So that's a very simple example in terms of designing for a circular economy. There's a furniture company, like office furniture company in the States, that has been doing design for a circular economy for a long, long time. They essentially take the furniture back and reuse the material for the next furniture products, unless they can actually fix it and use it again to start with. But so design the end of use treatment into the product from the outset.
Yes, these are very good examples indeed. I realize that some of you said you cannot type in the Q&A, so I will go into the chat to check in a minute, but we have a couple more questions in the Q&A here. The next one is a general question on how to integrate AI, quantum computing, and other frontier areas into sustainable development.
So where we see the frontier technologies used in the sustainability or sustainable development discussion is a lot around data collection, data analysis, of course, more so, and modeling forward. So as we are collecting more and more data, handling bigger and bigger volumes, trying to build digital twins of the world, the digital twin of the ocean, to actually look at what would happen if we take action X, Y, Z, and so on. So that is where the true technology use will have great impact.
Okay, so looking into the chat now, we have an interesting question that concerns IEEE specifically. How would you suggest establishing a chapter in an IEEE section addressing sustainability and climate change? This person says they have not found any mechanism to do this. Okay,
so the mechanism is local groups. So Google, look at the IEEE website, search for local groups, either under the vTool page or the MGA page. And there's a description, and local group specifically allows you to and encourages you to have a group under a section that combines IEEE members and non-members from the local community to work on a topic of interest that is related to the IEEE fields of interest. And sustainability, climate change, circularity are all topics of big interest to IEEE.
And how about Collaboratech?
The local group would actually have a Collaboratech site associated with it. So as soon as the local group is formed, there is a Collaboratech group associated with it for the members to use. In Collaboratech is a sustainability-related group as well. But I think if you really want to locally work together with your local communities, the local group is the way to go. And you can have multiple. I don't know from where the question comes, but I mean, if you are in, say, Turkey section, you may want a local group in Istanbul and in Antalya and other places. So it's a very flexible structure.
And of course, you could also volunteer for the SUSTEC initiative, in which you will build a network of other IEEE members who are interested in this topic. And I think another thing we could mention, Maike, perhaps is the Industry Connections group that the Standards Association runs. There are several groups on sustainability in this program.
Yeah, there is one on sustainable maritime. There's one on the water energy nexus. There's one on green hydrogen, one on nuclear power, one on data centers, I think was just approved this past week. Yeah, last week or this week. Then we have the Planet Positive 2030 program that I have the pleasure of sharing. And we are building actually communities now, starting with Miami, around the globe, hopefully, to focus on community pathways to more sustainable communities.
Great. So I think this is a quick tour on opportunities for in IEEE. Let's look at another question that came in the chat, which was about how about replacing battery consumption with energy harvesting and storage capacitors, for example?
I think it really depends on what type of battery we are talking about, and there's a lot of development happening right now. So we have batteries from our laptop and phone batteries. We have batteries for heart pacemakers. We have batteries for cars. We have battery banks for backup for renewable energy providers, and so on. So I don't think I want to go specifically making a recommendation, but I do think that what we need to do is look at what type of battery we use where, in which context. And there's a lot of development around chemical batteries that is happening right now that is using less precious metals, or less less hazardous, and so on. So I think battery technology and equivalence is going to be a topic to stay with us as we are moving through the energy transformation. And just to look at it, the global consumption of energy, which is like electricity, of course, is part of it, but heat and so on, only about 15% is from renewables. The rest is all from fossil fuels. And that includes the renewables, actually, I should say differently, is clean, because that already includes the nuclear power production. So if we consider that we have to change the energy that we are currently using for combustion based on fossil fuels, is like more than 80% of what we are using today, then we have an awful lot of renewable and clean energy generation to do. And if a lot of this is directly electricity, then we have to also build quite a bit of storage infrastructure. And that gets us back to batteries.
Yes, and so it is time for us to end our webinar, but Maike, thank you very much. I think we can also mention on this topic, we will have a talk specifically dedicated to batteries, recycling, yes, and reuse in this series. So please continue to join the series. Our next talk in 4 weeks at the same time will be held by, presented by Alan Booker on regenerative design, which is a very big piece of the circular economy. And Alan is an excellent speaker. So please join us back in 4 weeks. And thank you for attending our first webinar and for your participation. And thank you again, Maike, for your presentation.
Thank you very much for the opportunity. And I'm looking forward to Alan's talk.
Yes. All right. We'll see you in 4 weeks, everyone. Thank you.